Today, we're going to talk about metal materials. Let's go. There are several important principles to understand when creating metal materials in Unreal and Unity. Today, we're going to go over those as we make this metal material. We'll start out in Unity and then switch over to Unreal in a minute. All right, let's start out by creating a new shader. So I'm going to go shader graph, HDRP lit shader, and we'll just call this test metal. And I will open this material up and we're ready to get started. The first thing to understand about metal materials is the metallic input. So let's just turn on our main preview here. You can see that our metallic input is set to 0 right now. And to make a surface metal, this input needs to be set to 1. Now, you can do this either just by setting this number to 1, or you can create a texture mask where the metal areas are painted white and the non-metal areas are painted black, and pass that into this metal port. But here's the important part. Switching this value from 0 to 1 is changing the underlying behavior of the shader. It's kind of like having two shaders in one. You have a non-metallic shader and a metallic shader, and you can switch between them using this value. The main thing that changes when you set metallic to 1 is the behavior of the base color input here. When metallic is 0, the base color represents the albedo, or the diffuse color, of the object. But when you switch metallic to 1, the base color now represents the reflectance color of the surface. Objects that are made of metal don't have diffuse color at all, so their diffuse value is represented by black. Instead, their color comes from reflection. And so the base color input port switches from albedo to reflectance. This is a really important principle to understand. The input to base color for metals represents the color and brightness of their reflections. Just so we can get a little bit better results, I'm going to set our smoothness to 0.9. And now you can see that our metal has a lot of reflection going on here. But if we set metallic to 0, now you can see our reflections are significantly dulled. So when metallic is set to 0, base color is the albedo or diffuse color. And when it's set to 1, base color represents the brightness and the tint of the reflections. Next, it's important to know that in order to make metals realistic, you can use specific color values for the base color port that have been measured in the real world. There are several different places online where you can find these color values, and I'll list them down in the description. But conveniently, in Shader Graph, there's a node that brings these values in. It's called metal reflectance. So all you need to do is add a metal reflectance node and pass it into the base color, and then just select the type of metal that you want to create. By default, metal reflectance is set to iron, but I can drop this box down here and pick silver or aluminum or gold or copper. In this case, we're going to go with copper. So I'll just select copper here from the dropdown. And now we have our copper shader. Pretty cool. Okay, just so that we can start making a real material here, I'm going to add a sampler texture 2D node and bring in our normal map. And we're just going to use the rock asset for now. And so I'll just search for the rock normal map and set my sampler texture 2D to normal. And then we'll just plug our normal right into the normal tangent space input. All right, so now that we have our normals in here, it's going to make our preview look a little bit interesting because these normals are specifically intended for the rock in our scene. In fact, why don't we go ahead and apply this material directly to that rock. So I'm going to come down here under Test Metal and open up our shader, and there's our material. And when I come back to our scene, I'm just going to select this rock asset here and apply our Test Metal material to it. And now you can see we have a nice metallic looking rock. It's made out of copper. All right, there are two more items that I want to talk about with regards to metal shaders. The first is specular occlusion, and this is an important principle. We're talking about specular occlusion or reflectance occlusion. Specular occlusion is similar to ambient occlusion, except instead of the ambient light that's being blocked, it's the reflections that are being occluded. So basically, specular occlusion happens when the object is reflecting itself instead of the environment around it. And these self-reflection areas in cracks and crevices need to be darkened, or need to darken the reflections. This can be done in a couple of different ways. First, let's add another sample texture 2D. And this time we're going to bring in the mask texture for this rock asset. So let's do a filter for rock again. And we're going to use rock A mask map. And so this texture has the ambient occlusion in the green channel for our rock. And what I can do is just take this ambient occlusion and wire it directly into the ambient occlusion input on my master stack. So passing our ambient occlusion into the master stack ambient occlusion input port here doesn't automatically make this into specular occlusion or reflectance occlusion. In order to do that, we need to come up here into our graph inspector and switch to graph settings and come here under advanced options. And here it says specular occlusion mode, and it defaults to from AO. That means our reflectance or our specularity is going to be occluded from whatever gets passed into the ambient occlusion input. However, there are a couple of different ways of doing this. What if we set our specular occlusion mode to off? And now all we need to do is take our ambient occlusion and multiply it by our metal reflectance value. So now I'm going to take the green channel here, which is our ambient occlusion, and multiply it by our metal reflectance. And now we can pass this into base color. And that does something very similar to getting specular occlusion from our ambient occlusion input here. But it's important that if we do this method, if we're multiplying our ambient occlusion by our metal reflectance to get specular occlusion, that we not do the other method as well and use our ambient occlusion here to get specular occlusion. So if we're multiplying it here, then we need to make sure in the inspector that we turn off specular occlusion mode here, so we're not doing both, because that'll just make things extra dark. All right, so we've got our metal reflectance for base color. We have our ambient occlusion and specular occlusion, and we have our normal map. The last thing that we want to add is just a little subtle hint of iridescence. So let's talk about that really quickly. Iridescence happens because the surface of an object has a thin film on the surface, or sometimes really nice bright metals have iridescence as well. And in order to create the iridescence, we're going to first create a Fresnel effect node, and we're going to set the power to 2. What the Fresnel effect node does is it acts as a mask where white are surfaces perpendicular to the camera and black are surfaces facing the camera. And now what we're going to do is we're going to take this mask and use it as our UV coordinates for sampling a gradient. So let's add another sample 2D node, and we need to grab our gradient texture, and there it is. So this is a texture that represents all of the colors of the spectrum, and it loops from red back around to red. And that's important because we're going to tile it several times in the space of this Fresnel effect node. So I'm going to use the Fresnel effect as the UV coordinates to look up our gradient. So what you can see here is we're all the way on one end of the gradient. And then as we go from black to white, we go from red to magenta to blue to cyan to green to yellow. But in order to make this behave a little bit more like real iridescence, what we can do is take our Fresnel effect value here and multiply it by a value that will allow us to control how many times this gradient pattern is repeated. So I'm just going to add a slider value here so that you can see what's going on. And we'll set our slider value from 0 to 4. And now, as I slide this value, you can see that I'm multiplying my value by 4 here. But what we actually need to do is add a fraction node. So whenever we go over 1, we're repeating our value. So we're going to multiply by our slider and add our fraction node. So let's take a look at what this looks like. Now you can see that our gradient is repeating here on the edges. So we're going to go from 0 to 1, 0 to 1, 0 to 1 multiple times. And we'll use that to pass into our UV coordinates for our gradient sample. And now you can see that our gradient samples over and over and over, and it kind of loops. And that's the effect that we're going for. So now what we can do is take this color here that represents our iridescence. Actually, you know what? Before we do that, let's wire this directly into our color so that we can see what our object looks like with just this rainbow pattern applied to it. All right, so now you can see as we rotate around the scene, you can see that the rainbow pattern kind of animates because its coordinates are dependent on our view angle, whether the object's surface is pointed directly at the camera or off in a perpendicular direction. But this effect obviously is way, way too heavy. And so we need to come in and tone it down a bit. And so what I'm going to do is take our metal reflectance here, and we're going to blend between our metal reflectance value using a lerp node. So I'll plug metal reflectance into the A port of our lerp, and I'll plug our iridescence spectrum gradient into the B port of our lerp. And now to get the right value, I can add another slider here. This is a parameter that you'd probably want to expose, but I'm just going to use a slider for illustration. So if we set our slider to 1, we're going to get 100% iridescent values, and if we set it to 0, we're going to get none. So we probably just want to set this down here to something subtle like 0.1, so that we just get some very subtle iridescent values there. All right, and now we can multiply the result of this by our specular occlusion. And I'm just going to clean things up here and rearrange our grid. And we can pass the result into our base color. Okay, now if we take a look at our preview here, you can see that just the really subtle iridescence around the edges. And if we switch back to our scene, now we've got our nice metallic shader, and you can see there's just some really subtle color variations going on because of the iridescence. Now you might want to make this a little bit more subtle, just depending on what you're looking for, and you could adjust this value here so that the lerp was like even lower. We could set it to like 0.05, and it will give our iridescence just a hint of color variation in our metal. So pretty cool. Now, if you were using this in production and you wanted to be able to create a shader that had some areas of metal and some areas of non-metal, you would take this mask texture here that's got the ambient occlusion in the green channel, and in the red channel you could paint a mask that was black in areas that were non-metal and white in areas that were metal. And then you could also create a texture for the base color, and you would use the values that are coming out of metal reflectance. You'd have to paint these values into your base color texture and then paint other colors for the areas that were non-metal. But you'd want to make sure that you were using these proper metal values in your texture so that your metals will stay nice and bright. That's one thing that I forgot to mention, that metal values are always fairly bright colors because metal reflectance is high. And if your color gets too dark, it stops looking like a realistic metal. All right, well, that's it for metals in Unity. Let's switch over to Unreal and I'll show you how to create some nice metals there. All right, here we are in Unreal, and you can see that I've created a shader that does exactly the same thing as our Unity shader. First of all, I set our metallic input to a value of 1 to convert our shader from a non-metallic to a metallic version. And this is a value that you could set in a texture if you wanted to, where you painted non-metallic areas black and metallic areas white in that texture map. I've also set our roughness to 0.1 so that our model is nice and smooth, and you can see that in areas where I don't have the normal map applied. This normal map is the one that's applied to rocks, and you can see that I've got it right here. It's T rock mesh N, and I've plugged that into the normal here. And then I have my color right here, and this is the color that we're using for copper. Unfortunately, Unreal doesn't have a nice handy node that has all of the metallic values built into it like Unity does, but that's okay because we can just add a Vec3 value by holding down the 3 key and clicking, adding a Vec3 value, and then entering the correct color here. And like I said before, all of these colors for the different kinds of metal are available online, and I'll post links to those down in the description. So this is the correct value here for copper, and you can see that I'm doing I've got my ambient occlusion here, and I'm plugged it into both the ambient occlusion as well as multiplying it by my reflectance color here. So I've got my ambient occlusion, I'm passing it into this lerp value here, and what this does is it tones down the ambient occlusion because by default this ambient occlusion is kind of dark, and so what I've done is passed it into the alpha of a lerp, and then I'm lerping between 0.5 and 1, and what that does is it makes it so that the ambient occlusion never gets darker than 0.5. It doesn't go all the way to black. So then I'm using that ambient occlusion to multiply together with my base color, my copper reflectance value here, and that ambient occlusion is becoming specular occlusion there because I'm multiplying it together with that copper value and then passing it into base color. And then all the rest of these nodes here are how we're handling the iridescence. And so what we're doing here is we've got our normal coming out. We transform our normal from tangent space to world space, and then we pass it into the normal socket of our Fresnel node. And the Fresnel node is going to create a really nice gradient from black to white, where it's black when the camera is looking directly at the surface, and it's white when the surface is perpendicular. Then we take that Fresnel value and multiply it by 4, and then do a frac on it so that it's wrapping around. And we use that wrapping to then sample our gradient texture. It's not represented very well here, and so I want to show you what that texture looks like here. It's just a gradient that passes through the colors of the spectrum from red to magenta to purple to blue to cyan to the green to yellow to orange and back to red. And this is the value that we can use to apply our iridescence. So we sample it with this Fresnel value. Actually, let me show you what this looks like if we just pass Fresnel into base color. And so what you can see here, if I switch this to unlit, is that we've got black in the middle and it goes to white on the edges. And then when we multiply it by 4 and take the fractional portion of it, it looks like this. So you can see it's passing through the black to white gradient several times as it goes toward the edge. So that's the value that we want to use as our UV coordinates for our spectrum gradient here. So if I pass this into base color, now you can see I've got this nice spectrum going along. And this is what we use to blend together with our copper base color here to create the iridescence. So you can see that I'm just lerping between our iridescent gradient here and our copper color with a value of 0.1. And the reason that we're doing 0.1 is just to keep that iridescence kind of subtle. You can see that it does add quite a bit, and it's just kind of a subtle color gradient. Even 0.1 might be a little too much. If we turn it down, we can set it to 0.05 and kind of tone that down. And it gets scattered around a little bit because of the normal map. And then we multiply it again by the ambient occlusion, and we pass that into base color, and we end up with a nice metallic shader. So that's pretty cool. And if we switch over to our scene, you can see here we've got our nice big chunk of copper rock. But the principles, again, are that we use the metallic input of the root node to switch our shader from non-metallic to metallic. And then once we're in metallic mode, it's important that we use a correct value for the metal that we're creating. This one is copper, but there's a whole set of correct values for all the different kinds of metal. And then we need to handle our specular occlusion correctly. We can use ambient occlusion for that. There are fancier ways of doing specular occlusion, by the way, but this is the simplest way to just use the ambient occlusion itself. And then if you want to, this is completely optional, you can add the extra subtle iridescence in there just to add a little bit nicer touch to it and add that nice color variation that the iridescence provides. All right, so that's the basics of metallic shaders. I hope you learned something cool today. Let me know if you have questions down in the comments, and if you like the video, give it a thumbs up. Thanks a lot for watching, everybody, and have a great week.